Hey guys, this is our first chapter review, so let's go ahead and get started and dive right in. The first problem, you're actually not going to have a problem like that on the test, so don't worry about that one. Let's dive right into the second question here. It says to draw a segment AB and put an X some point between. So here's X, some point between A and B. And you want to label our things. AX is 3x plus 4, and then we have 7x minus 12, and the whole thing is 6x plus 20. So we should use segment addition postulate, add them up, set them equal to 6x plus 20, we get 7 as our value. Then it asks us to not only find x, but to find AB. So we're going to actually take AB, which is the whole piece here, which we know is 6x plus 20, and we're going to plug 7 in, and that's how we get 62 as our answer. Okay. Moving on to our next problem, number 3. This is just a basic vertical angles question. You're just going to set them equal to each other. When we set them equal to each other, we get x equals 9. Now we're looking for ABD, which is this angle here. Okay, so we plug 9 in here, we get 30 degrees for this angle, but these two angles should add to 180, so that's why this is actually 150 degrees is our answer. Alright, just a little picture drawn for us. I'll see if I can just zoom it in real quick. Make it a little easier to see. Okay, so we got a right triangle, an equilateral triangle, a scalene, an obtuse triangle, and a scalene acute. Okay, so I'm going to zoom that back out. Alright. This one we're solving for x. We know that these two angles here are in a right triangle, so we have the right angle right here. Well, if there's 90, these two have to add to 90, so that's why I went ahead and set them equal to 90. Solve, and we get x equals 20. We're just solving for x. Okay. On the back, we got question number 6, and a lot going on here. We're trying to solve for x. As you can see right here, this angle and this angle right here are actually alternate interior angles. Okay, we have to pick both of them. So these two are, even though it's kind of tricking us. So what we have to actually do is two things. We can set these two equal to each other, or I know that these two should add up to 180. So I could do that as well. So we did that. We got 78 plus 3x equals 180. And we end up with x equals 34, or I could have set these two equal to each other, and that would have been 3x equals 102, and you notice it's just this piece right here, and again we would end up with x equals 34. Okay? Alright, this is a really good question here that I get a lot. 75 and 70, you got to plug them in. Which is the biggest? Let's go ahead and, again, I'm going to zoom it back in to help us get a little closer picture of this. You want to look at one triangle at a time. So looking at just this one triangle, 75 is the largest, so the biggest side is AC. But when we look at this triangle, the biggest side is not AC. Across from AC is 50. So in fact, actually 70, AB is bigger than AC, because AC is involved in this triangle. So even though 70 is not the biggest angle, if you look at relationship between the two, AC is the biggest of this triangle, but AC is a part of this other triangle here, and 70 degrees points to AB. So the largest angle is actually AB. Okay? I think if I click that, that goes back to the normal. No? Just tried it, whatever. Try new things. Okay? And then here we go, we get number 8. If A is supplementary to B and X is supplementary to B, what must be true? Again, I like to draw a picture for this. A and B. They're supplementary to each other. Well, let's do 100 and this one 80. So A is supplementary to B and X is supplementary to B. So X would have to be 100 then as well. What's that must be true? Well, A must be equal to X. They're both 100. Okay. Find the slope of a perpendicular line to the line passing through 12, -5, and 8, -3. Put it into slope formula, and then we have to go ahead and do the opposite reciprocal. Okay, so don't forget that we want to do opposite reciprocal for our perpendicular lines for the slopes. Okay, this is a perfect little picture here. It says D is perpendicular to E, D and E. F is perpendicular to E. What must be true? Well, D and F are going to be congruent, and that's because corresponding angles are congruent, then parallel lines. Okay, so that's how we can tell that. Okay, what type of triangle has a hypotenuse? Right. Where is it? Opposite the 90. Okay, hopefully that one was pretty quick. There it is, the hypotenuse. The hypo. And last but not least, what type of triangle has a vertex angle? Where's the vertex angle? The isosceles triangle has a vertex angle. It's between the two sides, the two congruent legs. Okay, so it's right here. Vertex angle. Alright, last piece, number 13. We'll go ahead and zoom in again for these pictures here, describing our different triangles. So a median, it goes from the vertex, and it cuts the opposite side in half. An altitude goes from the vertex and creates a 90. An angle bisector cuts an angle in half. Okay? And then perpendicular bisector is the only one that does not go through, or doesn't necessarily go through a vertex. It just cuts a side in half and meets it at a perpendicular angle. Okay? Alright. Next question, number 14. We have a triangle with different points. Find the slope of the perpendicular bisector of xz. The great thing is you don't really have to even graph it. You just kind of have to know where the picture is. And if we're saying we want to find the perpendicular bisector of xz, all I have to do is find the slope of xz. So the slope of xz is denoted by this equation. So we actually get negative 18 over 6. The perpendicular bisector means I'm going to have to do the opposite reciprocal and flip it. And that's how we get 1/3 as our answer. Number 15 says using the same triangle, so from the one above, not 17, but should say 14. Find the coordinates of A if ZA is a median. So ZA is a median, which means it is in the middle of XY. So we just found the midpoint using midpoint formula of XY. That's all we had to do, and that finds me point A. Okay? Number 16. Number 16, we gotta draw a picture. I want to list the angles in order from smallest to greatest. So we label AB, AC, and BC. And we know the perimeter is 32, so we add them all up, set them equal to 32, we get x equals 5. Then we plug 5 back in, and we get 17, 12, and 3. The smallest is going to be opposite the smallest side. So the smallest angle is opposite 3, which is A. The next smallest is opposite the 12, which is B. And the last is C. So this is from smallest to largest. Okay. Last but not least, number 17, we're doing the same thing but kind of almost backwards. Okay. This time we're given angles. What we know about angles is that they add to 180. So I'm going to zoom in on this one. Okay. So I have my angles all posted in here. I know I should add them all up, set them equal to 180. When I do that, I get x equals 18. Okay. Once I get x equals 18, I should be able to find all the different angle measures. Okay, so this is all of our angle measures. And what we want to do is we want to go ahead and pick the opposite side. We're going from smallest to largest. So 45. From 45, I go out, and PR is the smallest. So PR is going to be our smallest. After that, 61. So I'm going to go out from 61, and QP is our next smallest. And then the largest is opposite of 74, which is QR. Okay? So there's our answer. Alright guys, hope it's a good one. See ya.